Hello, dear students. My name is Dr. Halkurt. I am glad to be a course lecturer of the module of communication principle. And it's the first lecture, and we start with the basic component of communication system. In the slide, we explain the history of communication system. As you see from the picture, that's the communication system. Uh, Basic communication system started with making a fire. When the ancient people want to send a signal to other people in some far places, they usually make a fire. And when the smoke rises, the other side, which is the receiving side, detected something happening in that place, which is a kind of signal for awareness. And later, it is developed and in 1844 telegraph is developed and later converted to telephone and radio and TV. And nowadays we see different kind of communication systems around us, for example smartphone, laptop, and we use different we can get benefit from different type of communication systems like 3G, 4G, 5G. It is all of the kind of communication system. And later also new device will be produced, maybe some of them unpredictable now. It is growing technology which started from small system and developed to more advanced system. uh, Related to the communication system, we have International Telecommunication Union. It's a kind of organization which is started in 1865. It regulate the basic protocol and standards for communication system. They facilitate some basic works of communication systems like develop ICT and telecommunication standard. They make a standard and uh, produce some kind of regulation which let different devices communicate to each other. For example, the Bluetooth device in the mobile can be connected to the Bluetooth device in your car on in your laptop with your headset, because they have same standard and same protocol to communicate with each other. Also, they manage radio spectrum and satellite orbit. They provide different frequency range and frequency spectrum for specific communication system, which has help to not produce interference. Somebody use specific band and the other companies use different frequency band to avoid interference between signals. And it's a basic work of ITU, which is International Telecommunication Union Organization. Basic communication system usually contain three different process or three different blocks, which is transmission, which is responsible for sending signal, processing signal, which is between transmission and receiving, and receiver side at the side which receives the message or receives the signal. Others explain it in this uh, figures. We start with the basic signal. If we consider our sound, my sound, for example, is a basic signal, which is sound signal, and this signal should be converted into electronic signal by the source of microphone. This microphone, which I speak to, convert it to electrical signal, and later we are at this stage. Later, some electronic processes like amplification, removing noise, apply to this signal, and later it will be transmitted to the air by the help of antenna. And when the signal produced or propagated into the space, it's an electromagnetic wave, and the electromagnetic wave can go through the air and reach the receiver side, and later the reverse process will be happen. The electromagnetic signal will be converted to electrical signal, and electrical signal by speaker converted to the sound signal, which we can hear now. We can hear my voice. It's a basic explanation of the communication system. which we basic signal we say ST, and after input it will be input of the transducer, it will be converted to message, which is we say MTXT, and the communication system between them, and later it is received by the receiver. Now we go to further explanation of the different type of signal. We have some signal, it is continuous. We have digital and analog signal. We have periodic and aperiodic signal. In this slide, we will explain what are the differences between continuous time or discrete time. In this slide, there's a explanation about different kind of signal. This signal, which is started continuously, with the time, it's a continuous signal because there is no discontinuity between its point. In here we have signal, in here, in here, in here, and so on. But in this signal, let's call it discrete signal. Why it is discrete? Because we have only at these points. In this point, for example, we don't have any signal, so it is discrete. Also, the signal, just call it continuous. This one, call it discrete. Some or other explanation, we have analog and digital. So in continuous signal, we mathematically we can express like it, which is xt equal to cosine 2 pi t. What's a cosine signal? We learn is that cosine signal will be like this. Here's a cosine signal, for example. It is a continuous signal, so it is called continuous signal. But if you wanted to make it discrete, it is called it is expressed mathematically like yt equal to x for n equal to 1, 2, 3. So if we wanted to draw the same signal by in discrete form, it will be like this, something like this. So we have only some points which is called it discrete. In terms of analog and digital signal, maybe it is clear for you that we have digital and we have analog. For example, simple explanation about it is a digital clock and analog clock. Maybe it is clear for you that we have digital clock, which is consists of numbers 1, 2, 3, 4. But when we have analog signal, it is just movement of the needle of the clock. Let's explain in terms of signals. This signal call it analog. This signal call it analog. Why it is analog? Because we have different value. So if you present the GT, what's the amplitude of the signal? In here we have, for example, 1, 2, 3, 4. We can say 1, 2, or 3, and 4. So the amplitude of the signal at this point is 1.5. At this point equal to 2. At this point we have 3. At this point equal to 4. And so on for the discrete analog signal. But when we speak about the digital, only we have two value. We have value of 1. Also we have value of 0. So all of the digital signals consist of two values only. When we reach the amplitude, great amplitude, we say it is 1. When we reach the small amplitude, we say it is 0. So in here we have a 0, we have a 0, we have a 0, but at this point we have 1. So the digital system represented by 0 and 1, and all of the devices like computer, smartphone, all of them based on the stream of digital signals, not analog signals. Also, another term is should be explained about periodic and aperiodic signal. What is a periodic signal? A periodic signal is a type of signal which is reproduced itself at the same way. So we can say that later. Maybe you have some. No, you don't have any other picture. Periodic signal. This signal can be, we say, is a periodic. The extension of the signal is like previous. So but the signal, because it is not extended in here, so you cannot say it is periodic or aperiodic. But simple explanation is that periodic signal has a form which is reproduce itself. the signal are the same along it is along it is along a time, but a periodic signal, it is a signal it is not reproduce when the first cycle go, second cycle not like the first cycle, third cycle not like the second cycle. Later we will explain it more in more detail. Now we go to it is explained in here, it's fine, it's fine. Periodic signal, we see this signal as a periodic because in this cycle, if you take this cycle, if you take this cycle, it's the same, this cycle, it's the same, this cycle. But this signal is aperiodic. Why it is aperiodic? Because we don't have continuous like signal. In here, we have some cycle, in here we have different cycle, in here we have a different cycles. So the signal call it periodic, this one is called aperiodic. Another term which will be explained, or it is very important to understand, is a harmonic signal. Any signal in communication system represented by its frequency. If we take this signal, for example, we can find frequency for the signal. We have lambda and f frequency equal to 1 over lambda, or c over lambda, sorry, c over lambda, and there's a opposite proportional between f and lambda. So when the frequency increases, the lambda will be reduced, and for any signal, when it has a specific frequency, if another signal near from it, we face something called interference. And for the term interference, we have a problem with the signal frequency and harmonic frequency. What's the meaning of harmonic frequency? Harmonic frequency is a signal which has similar frequency or multiple of the number. For example, when we have 2, 4, and 8 will be harmonic frequency for the basic frequency. Component in communication system, as we explained it before, but we explained it in terms of mathematical denotation, mathematical notation. We have input transducer, which is ST, and this ST will be converted into message signal in the transmit, or before going to transmitter, which is called input signal like audio, video, or image, and later modulated signal, which is input signal that has converted to the electrical signal at this stage. And later, this transmitter make some different type of electronic process like modulation, which is modulate two signal with this message signal and with carrier signal, which later will be denoted by PTX, which is modulated signal, and later some kind of noise will be introduced with the signal, added to the signal randomly, which is unwanted signal. And at the receiver side, also we have wired or wireless transmission line or transmission medium. In the transmission medium, the signal transferred from transmitter to the receiver, and as the receiver side will receive the signal, which is modulated signal, also contain a noise. We have to make a reverse procedure to get message signal from the modulated signal, and later we get RT, which is a received signal which we want. So we have generally we have three components of communication system. As we explained it before, we have transmitter, which involve modulation process, convert modulated signal MT to modulated signal PTX, and finally transmit the signal. At the transmission medium or transmitted channel, connecting the transmitter and receiver that enables the modulated signal to propagate through the medium. The transmission medium, it is between transmitter and receiver, maybe several kilometers, maybe thousand of meters. So after the transmission transmit or propagate the signal, the receiver can receive the signal, which is a modulated signal, and then convert to the original signal, which is message signal, basic message signal. Now we have an activity. You have to take time to get your activity, take your mobile phone and search what is the modulation process and how to improve communication system. So in this way, you have to find out what's the advantage of modulation signal, modulation process. Can we all the devices like our mobile phone, our TV contain modulation, uh, or any other devices need to use modulation, or any device without modulation, what happened to the signal without modulation process. So you have to search by yourself and find the answer. Also discuss it with your friends. Now we go to the transmission medium.